Welcome, Krish. It's a pleasure to be speaking with you today.
Thank you. Thanks for the invite. I'm looking forward to this conversation.
Yeah. So my guest today is Krishna Subramanian, also known as Krish. He's the founder and chief research advisor of Rishidot Research, and a cloud celebrity in his own right. I've been following Krish for a long time between his writings and his Twitter posts. He's an influential cloud blogger and among the top thinkers when it comes to cloud computing. And there's many media outlets who have, I'm told I am not on camera. Let me keep going. And many media outlets have recognized him as an influential voice in cloud computing. All right, I'm being told there's a voice echo. Give me a sec, let me try to fix this.
Sure. Check, go to the setting and check if you have echo cancellation turned on or turned off.
Yeah.
Cam bar mic setting.
Let's see. All right, sorry for technical problems. Hang on while I sort this out. Okay. All right. Okay, so I'm told we're better off now. So let me restart that, and apologies for the technical issues. So it's my pleasure to have you here, Krish, today. Krish is he's a founder and chief research advisor of Rishidot Research, and a cloud celebrity in his own right, an influential cloud blogger, and among the top thinkers when it comes to cloud computing. I'm not alone in sort of this recognition. SAP considers him to be one of the top 50 influential voices in cloud computing. Forbes considers him to be among the top influencers as well. And CRN Buzz considers him to be among the top influencers in cloud computing as well. His core research areas include cloud platforms, infrastructure, and big data. And he recently authored a white paper titled The State of Serverless in the Enterprise. And he's here today to share his insights on just this topic. So Krish, it's really a pleasure for you to be here and sharing your insights on this very important topic with our audience.
Thanks, Roderick. It's a pleasure of mine to be part of this webinar. In fact, I'm looking forward to this discussion with you, and my respect for you as well as NIMBELLA is mutual, and I've been following NIMBELLA since early days, and I'm pretty excited about the kind of work you're doing, and looking forward to this discussion.
All right. Great, Krish. So I'm going to bring up your slides. And they're live now, so you can take it away.
Thanks, Roderick. Thanks to the NIMBELLA team for giving me this opportunity to talk about serverless in the enterprise. The topic I am going to discuss is how serverless computing is transforming developer experience as well as operations experience in the enterprise. And then from my experience talking to enterprise customers as well as looking at what is available in the serverless landscape, I have put together some considerations for picking a serverless platform. I hope this webinar as well as the white paper which we have published already is useful for enterprise decision makers to understand how they can leverage serverless platforms to sort of like streamline their modernization strategy. Let's set some context. Let's talk about how serverless evolved and then talk about its current trend, the current trends that's happening in the enterprise. In 2014, approximately around the time frame, Amazon launched Aws Lambda. They offered a cloud abstraction that imposed constraints on the compute resources as well as the application architecture, so that they could give a developer interface. Developers can just write their application code and push it to the API for the serverless abstraction, and the application will be live, and it will automatically scale and take care of the needs based on the traffic that is coming to the application. That was revolutionary at the time because it made it easy for developers to push applications, but the constraints imposed on the application architecture because of the way cloud providers were managing the underlying resources, it limited the use cases. In fact, it was good for deploying stateless applications, but when it came to complex applications, it was not enough. So then many other serverless platform came out, and that led to what I call a second generation of serverless platform. They slowly removed the resource constraints underneath. Because of that, they were not imposing any application architecture constraints. So this sort of opened up a lot of possibilities, and functions as service, that is the name given to the serverless compute service that is offered in the industry, became an attractive destination for developers wanting to deploy many different applications. Now, the term serverless has moved beyond just compute into storage, database, and a few other services, allowing developers to use these services without having to worry about bringing up these services or running it and handling day-to tasks. I think this led to a lot of interest in serverless, but the natural question that arises is, okay, Kubernetes has been successful. Kubernetes is well embraced by developers and operations, and enterprises are using Kubernetes. Why not use just Kubernetes? Well, containers gives developers a seamless developer experience, and then Kubernetes allows organizations to easily deploy containers and scale up and down without having to worry about managing the scaling. Why not use Kubernetes? That's the natural question that I come across when I talk to enterprise customers about using serverless for accelerating their modernization journey. So I have to say Kubernetes is a great abstraction. It completely changed the way applications are developed and deployed, both in startups as well as in enterprise customers. So Kubernetes is great for the industry, but it comes with certain complexities. For example, the developer experience is suboptimal because developers need to handle the YAML configuration files needed to deploy their application. So if it is a simple application, it's no-brainer. You could easily deploy it and it's not a problem. But when the application is complex, the YAML complexity literally kills the developer productivity. Then it also comes with some sort of a Devops overhead. If you want to put together all the necessary components to deploy your stateful application, there is a heavy Devops overhead with Kubernetes. And from the operations side, deploying Kubernetes, when taking a vanilla Kubernetes and deploying it on servers or virtual machine and making it work seamless, it includes a lot of operations overhead. Clearly, there is a need for a higher order abstraction that will simplify even the Kubernetes experience. So the higher order, we are looking at an abstraction that makes it easy for developers as well as operations, so that you can leverage the advantage given by Kubernetes in terms of using containers for a wide range of workloads, but at the same time have the productivity and efficiency that comes with a higher order abstraction. This is where serverless fits in. The serverless allows developers to just focus on the application logic without worrying about any of the complexities underneath that abstraction layer. It also allows them to seamlessly scale the application up and down. So these two make serverless the right abstraction for developers. Remember, in today's world, we are talking about developers as the kingmakers. My friends at Red Monk, they like to talk about developers as kingmakers. Even IT operations, which usually acts as a gatekeeper, has transformed themselves into enabler of innovation. Under such scenario, it is important that organizations focus on increasing the developer productivity, and serverless provides that abstraction that makes it easy for organizations to empower their developers to just focus on the application logic and not worry about anything, including deployment, the underlying infrastructure complexity, scaling, etc. Also, developers also allows you to gain fine-grained pricing advantage. So you don't pay by the hour for the virtual machine that is running on the cloud, you pay by the invocation. It's the case when it comes to public clouds, but even when you're using serverless platforms inside an organization, this allows you to build the respective team in a fine-grained way thereby making it more cost efficient than any of or running a virtual machine or even a Kubernetes cluster. And the operational overhead that comes with most of these serverless platforms is much less compared to deploying virtual machines or containers in the enterprise. So serverless is sort of like gaining a lot of traction. Initially, it gained a lot of mind share among the developers. Now it's also getting a lot of market share. If you go to Amazon reInvent conference, all the serverless sessions, you won't get placed to even get in. So that is the kind of traction serverless is getting, and slowly this mind share is getting converted into market share as more and more people pay to use serverless platforms. This is not just what I feel about serverless. In fact, some data available on the market, it says that global serverless market size is going to grow from 7.6 billion in the last year to more than 20 million in 2025 at a CAGR of 22.7. This is a pretty solid growth. In fact, even our internal estimates sort of agree with this kind of attraction. And we are seeing it as we talk to the enterprise customers. We are seeing more and more enterprises looking at serverless as the right abstraction they should be delivering for their developers so that the developer productivity is enhanced. And as I told earlier, Kubernetes is great, but serverless abstraction gives that kind of seamless experience, developer experience, and operations efficiency. People are moving towards serverless. This is not my own thoughts. Like the data that is coming from the industry, there is a Datadog report that talks about how AWS container users are embracing Lambda. In fact, 80% of the container users have already adopted Lambda. So clearly, there is a need to have that abstraction layer that removes any friction that comes on the way of developers. So the using serverless as an abstraction layer is a no-brainer these days. And if your organization is not using serverless abstraction, I think this is a good time to take a note on what is happening in the industry and probably adopt serverless as the abstraction. So now that I added my thoughts on how serverless is empowering developers to innovate rapidly and also making IT operations more productive, let's dig in a little deeper and talk about serverless in the enterprise. Serverless in the enterprise is there already. Some of the organizations have already embraced serverless. In fact, 3 years back, when I was in one of the conferences, I was talking to a large enterprise customer from Europe. They said that they have already embraced serverless in their organization, and they feel that is giving them the kind of developer experience they need to give their developers. IT departments in large enterprises are realizing that they cannot be the gatekeeper who add additional constraints to the developers. They should be empowering them by giving them a seamless experience so that their productivity is increased and they can innovate rapidly. So the serverless has already has been gaining traction in the enterprise, and there are some drivers that is changing the way serverless is adopted in the enterprise compared to individual developers and startups. In the enterprise, adoption of multi-cloud is real. In fact, a report that came from RightScale releases this awesome report on cloud every year. And the 2018 State of the Cloud report talked about enterprises embracing 81% of the enterprises embracing multi-cloud in their organization. In fact, Rishidot Research has some internal estimates that where we expect that by 2025, every enterprise will have at least 2 or more cloud providers in their organization. The driver for this is not like wanting to use different cloud providers in a high availability use case. It's more to do with giving the developers the right set of services. So the multi-cloud adoption is increasing in the enterprise. However, the multi-cloud comes with its own challenges. There are some operational headaches. There are some developer experience headaches. Then you need to train your developers to use the different cloud providers. These are significant challenges that come inside any enterprise that are adopting multiple cloud providers. So, and there is a trend that is reshaping the enterprise today. They want enterprise IT to be friction free. They want to give developers a friction-free environment so that they take the business requirements and innovate rapidly and take it to market fast. Success in today's enterprise market is defined by how fast you can take an idea to market. That is what defines the success today. If that is the metric for success, then it boils down to having a production pipeline, DevOps pipeline, that goes from developer laptop to production without any friction. How do you build a friction-free enterprise is the critical thing. They thought cloud is that nirvana that is going to make enterprise friction-free. Yes, cloud did remove some barriers, like you don't have to put a ticket and wait for weeks or months to get your resources, but it didn't remove the friction completely. Then they thought DevOps is going to sort of like remove all the friction. DevOps accelerated the production, but that didn't entirely remove the friction. There was still like a lot of friction in terms of decreased developer productivity because of the additional operational overhead that came with using cloud and DevOps. Then now, like with serverless, that could be a good abstraction that could reduce all the friction and lead to friction-free enterprise. So I am making a bold claim here that serverless is that foundation that is needed for friction-free enterprise. There are many advantages with serverless in enterprise. I will be talking about it in the next few minutes. So in short, serverless sort of like removes all the friction that is part of the DevOps pipeline from developer laptop to production, so that by standardizing the experience across the entire pipeline, you are removing the friction and making it easy for developers to push the code that goes into production and delivers value to customers. So serverless is going to be the foundation for any modern enterprise that want to innovate at a rapid pace. Having said that, let me highlight some of the advantages you get with serverless inside an organization. So serverless, the abstraction at the developer level allows you to sort of give the same developer interface across teams. So this means that there is no finger pointing saying that, hey, it worked in my developer environment. If it didn't work in production, it's ops problem. Or ops saying that, hey, it is not working here. That means developers didn't do something right. So all these friction points can be removed. And second, if when you're using multiple cloud providers, you need to train your developers on all these cloud providers. They have different consoles, different CLI, different APIs. Training them across all these cloud providers is an additional overhead and it slows you down. So by using a serverless abstraction, you can remove all these friction points. And also from an IT ops point of view, the fact that the serverless platforms are packaged from the layer above the server all the way to the developer interface means that the deployment is much more seamless than putting together like layering Kubernetes plane and then putting all the DevOps components needed on top of it and then giving a developer interface. That has a lot of ops overhead. With the serverless platforms, you can limit the ops overhead and make it much more seamless. And modern day serverless platform are taking advantage of Kubernetes underneath. That means the resources are used much more efficiently than what you can do with virtual machines. So there is a cost optimization advantage with serverless too. And the fact that the entire stack is packaged and taken care of by the company or the vendor behind the serverless platform means that there is a much smaller attack surface for which you need to worry than what will happen when you're putting together the entire stack one by one on your own. So clearly serverless brings in a lot of advantage for the enterprises, but enterprise is a different beast. Enterprise has some specific requirements that many serverless platforms cannot meet. For example, enterprises want different deployment models. They want to deploy it on premises. They may want to use a hosted serverless offering, or they may want to deploy it across multiple cloud in their own cloud account. So they require the flexibility in how these platforms can be deployed. So ideally, what an enterprise is looking for with a developer abstraction like the serverless abstraction is, they need to deploy it where on any infrastructure, but give that same standardized interface for developers. So that is one of their critical requirements. The second critical and the most important requirement is that enterprises have tons of stateful applications. If the serverless platform doesn't make it easy to deploy stateful application, it's a no-no for most enterprises. And as we all know, enterprise security requirements are much different from an individual developer who is using a serverless platform. So clearly, you need enterprise-grade security in any of the serverless platform you're deploying. So you need to make sure that they support integration with the IAM, which is already in identity and access management layer, which is already existing in all the enterprises. So we need to make sure that the serverless platform sort of help them enhance their security and not add additional challenges. Then most of the enterprises today, they have embraced Kubernetes in a certain level. So all these enterprises are, even if they want to go and use a serverless abstraction, they are looking for platforms that will support these Kubernetes environments. There are multiple reasons for that. They have already invested in Kubernetes. Then it makes sense to have a similar kind of stack in their organization. The most important point is they might be running some applications on their Kubernetes environment. Then the serverless platform, if it supports Kubernetes, then it will make it easy for them to put them all together, maybe within the same network, and they can manage it in such a way that there are no silos that exist in their organization. So serverless platform supporting Kubernetes environment is seen as a positive aspect of by the enterprise customers. And now, like compared to what it was 15 years back, now every enterprise wants open source standards. They see it as a way they can avoid some sort of a lock-in and future-proof themselves. So these are some of the enterprise needs any serverless platform should meet before they can be taken seriously inside the enterprise. I have checked out so many serverless platforms. Not all serverless platform could meet these needs. So it is important that as you evaluate the serverless platforms, you need to look at whether it meets the needs of your organization. So I have sort of put together some of the considerations from a developer point of view as well as ops point of view. And the white paper which I have published along with NIMBELLA, it goes deeper about some of these considerations. So from a developer point of view, you need to make sure whether the serverless platform supports the programming language your developers need and the data store that is needed to support the application. So if you want a relational database or if you want a key value store, it should be supported by the platform. Otherwise, the developers will incur very high Devops overhead, which will add friction to the rapid innovation which you are looking for. Second, developers may want to package their application in multiple formats. It could be a zip file, it could be a container. So check if the platform you are considering supports the kind of packaging your developers want to use to deploy the application into the platform. And the other thing is to increase the productivity of the developers, make sure whether it's integrated with the IDE they are using and whether it integrates with the other tools like Postman and other developer tools they are using. That is critical in reducing the friction so that developer productivity is enhanced and the advantage of serverless abstraction is taken care of to the maximum. Then you need to ensure that there is support for stateful application because developers are going to code their application to handle state. If there is no easy way for them to use the state, like an integrated database or key value store or object storage, then it is going to add a lot of overhead for them. They don't want that. So you need to make sure that the platform supports stateful applications out of the box. The other thing is with remote work that's been happening since beginning of 2020, and even otherwise, well before that, the collaboration tools are gaining a lot of traction in the enterprise. So you need to make sure that the serverless platform you support, you are picking up, has support for chat ops. If serverless platform makes it easy to integrate with all the collaboration tools, that is a plus point for that platform. So check if that is there, so that developers can take advantage of that and build their applications. From the operations side, as I already spoke about, way to have gentle migration. So even if you're not using Kubernetes environment, there should be a way to bring your legacy workloads and make it work alongside your newer workloads in the platform. See if the serverless platform offers support for gentle migration, so that you don't end up with the silos after the modernization. You should be able to put together all the workloads, legacy workloads and new workloads in the same environment and manage it seamlessly. So check for gentle migration support. And as I already pointed out, you need to ensure that the support for stateful application is available out of the box. The other thing you need to consider is whether there is integration to the identity and access management tool you are using, and whether that integration is seamless, and whether you can ensure the security as per the organizational policies. Then the other option is whether you can deploy it in any infrastructure you want to deploy, whether it is a public cloud, or you wanted to take advantage of a hosted FaaS offering, or you want to deploy it on premises, or you want to deploy it across multiple clouds. The platform should have that flexibility. If it is not there, then not having the flexibility will stop you from evolving to meet the business needs. And the final point which I want to highlight is how easy it is to deploy the platform and ensure day-to-day operations like monitoring, logging, and other things. Because if the deployment itself is going to add a lot of time, then it's adding friction in your journey. So make sure you pick a platform that makes it easy to deploy the platform seamlessly and make it available to your developers in a much easier way. These are some of the considerations I have put together based on my general conversation with developers and operations in the enterprise. But there could be some your organization specific requirements. Make sure the platform also meets those needs. Some of the use cases which I'm seeing in serverless are stateless application, where the state of the application is not maintained or carried forward for the next invocation or scaling. That's the straightforward use case. That's where for serverless in the beginning was built for that. You could invoke parallelly multiple instances and scale seamlessly. But enterprise needs are different. They need stateful support for stateful applications. Next generation platforms are supporting stateful applications today. And so similarly, using big data workloads like Hadoop-based workloads needs to be supported. And in fact, serverless platforms are a good use case for batch processing. Like in batch processing, you'll have a spike in load, and then they'll come down, and probably a spike will come later. By using a serverless platform, you can use the resources efficiently, so that you bring up the compute resources whenever the spike is coming for the big data workload and take it down. So the serverless is a very ideal platform for running big data workloads. Machine learning and AI. Serverless is not a good platform for training your model. But once you have trained your model on the local developer laptop or dev environment, you could easily deploy the trained model for public use by using serverless platform. With serverless platform and an API gateway, you can easily make that model available for consumption through that API. In fact, last week I was working on a project with some of the developers, and they put together, they deployed a machine learning model using serverless platform and API gateway, and made it available to their internal users in a matter of probably an hour or less. So it's very easy to sort of like put together, use serverless for deploying machine learning and AI workloads. The other thing is media processing. Serverless is a very good use case for that. If you want to process a large video file or process a batch of photographs, You just invoke the serverless compute, process it, and then shut it down. So serverless platforms are ideal candidates for media processing. So serverless has been gaining a lot of traction in the enterprise. And enterprise, as I said, enterprise requirements are different. And as an analyst, I evaluate multiple platforms on how it fits for enterprise needs. And I've evaluated everything from the platforms offered by hyperscale providers to enterprise software companies. And some of the results I have published in my GitHub account. I find NIMBELLA platform to match most of the requirements enterprises need. NIMBELLA is a platform built on top of open source standards. It takes advantage of Kubernetes, which is an open source software offered by the CNCF, which is Cloud Native Computing Foundation, and OpenWhisk, which is an Apache software. So the platform is built on top of these two so that it meets the open standards requirement of most enterprises. And NIMBELLA platform is available as a hosted offering in multiple cloud providers, and you can also deploy it on your own cloud account or on premises. It gives a lot of flexibility in terms of deployment. And with the developer interface NIMBELLA platform offers, you could have the same resource availability across developer testing and production environments. This removes the DevOps overhead, and you don't have these issues like, hey, it worked in developer environment. If it didn't work in production, that's the ops problem. That is the biggest friction point in many of the enterprises. NIMBELLA platform, by using the standardization, completely eliminates that friction point and finger pointing. So it makes it easy, even in the case of an outage, it makes it easy to do the postmortem without having to worry about dealing with the conflicts between human beings. And they offer out-of-box support for stateful application. They offer a database relational database out of box, key value store, object store, and file store, everything available out of box without any additional overhead for the operations and developers. And they are integrated with many chat ops platforms like Slack, Microsoft Teams, Mattermost, and others. NIMBELLA is also integrated with many developer tools like Postman. I think NIMBELLA meets most of the criteria which enterprises have, and I strongly recommend you take a look at NIMBELLA platform and see how it fits your need. I think I made a case for why serverless is the right abstraction for enterprises. And I also pointed out that NIMBELLA is a very strong platform that could meet most of your needs. If you want to learn more, go to this website, www.nimbella.com/whitepaper, and you can download that white paper and check out all this information. And if you want to talk about serverless, you could talk to me on Twitter at Krishnan or using the email krishnan@rishidot.com. Thank you very much. Now Roderick is going to take over and talk more about the NIMBELLA platform, and it is going to be an exciting conversation.
Thank you, Krishnan. This was really, really good. And even though I believe a lot of what you said, it's always interesting and insightful to hear your perspective. And one of the thoughts I had as you were speaking was, have we seen this before? If you look at the history and the evolution of computing, slowly over time, we've been moving towards what you called frictionless, right? More automation, higher abstractions, and there's been successes from past technologies. Taking more or less about the same things from the past. What, in your view, makes serverless the great enabler now? And is it perhaps that serverless is no longer a specific technology, but more so a methodology, an idea, if you will, that begets a lot of these benefits? Curious what your thoughts are there.
Yeah, it's the latter. In fact, serverless has emerged as this newer operations pattern that makes it easy for operations to deploy that developer abstraction that is needed for developers, because giving that abstraction to developers has been there for a long time. But what makes it easy for serverless is to bring in certain methodology to this to the way resources are deployed, so that it's easy from operations point of view, and also it's easy from a developer point of view in terms of deploying their application code without the additional hassles that usually come up with any other platform. So I think, evolution, first, cloud is a big enabler for this new paradigm shift. And now with Kubernetes, it's getting better and better. So I think the change in mindset plus the evolution of tools underneath the stack has, there's a convergence of these two that made serverless an attractive candidate today.
Yeah, thank you. So I'm going to pick up on a number of the themes that you've touched on and give the NIMBELLA perspective and really call out and highlight some of these points. So let me bring up my slides. All right. I think I'm good to go. So I'm going to focus a little bit on the NIMBELLA serverless platform. And it's really, in my view, about unleashing trapped potential within an organization. Krish did a great job on sort of highlighting some of the issues in the enterprise and why we've been looking for essentially this model of computing for a long time. So are things different today? And I believe that they are. And one way that I think serverless really transforms things is because we're in a world where it's an API-first reality. And which enterprise today isn't really building a cloud? It's not a cloud in the sense that AWS has a cloud or Google has a cloud, but they are building essentially these APIs that are accessible, whether internally within their organization or externally through publicly available APIs. And that in itself embodies a form of a cloud. I think this is where the interest in some of the technologies that that we're talking about here. And an NIMBELLA serverless platform is about normalizing the development in an organization and enabling serverless methodologies within that organization. And we do that in a way where we are leveraging the benefits of Kubernetes. And I'm going to talk about why we do that. But we're doing it in a way that hides Kubernetes from developers. And these serverless benefits that Krish talked about, and I'm talking about here, aren't just our musings. There's a most recent survey that I read from Coding Sans, published in 2020, late 2020. Really surveyed practitioners who are already using serverless and asked them, what are some of the biggest benefits you see from serverless and adopting serverless methodologies? And it has been essentially that. Hey, I get scalability mostly for free. This gives me or leads to speed of development, time to market, essentially, decreased system administration. And that, these themes start to touch on, trap potential within your organization, which now you can repurpose to delivering value for your business. And the adoption of serverless has really been spread around across many industries, financial services, consulting, IT consulting, education, healthcare. It's in lots of industries, including some regulated industries. And that's because, as Krish said it, the developers are the kingmakers. And once you start developing in this way and you give this power to developers, it's really hard to go back. It's so empowering to essentially develop in this model. And the use cases have been growing. So when serverless and serverless functions came about with Lambda about 6 years ago, maybe it was predominantly used for REST APIs or some batch processing, but now we see it used more and more. And as developers are using this technology and this methodology for more applications like chatbots, like machine learning and artificial intelligence, what we're seeing is that some of the initial constraints that were there have been evolving and eroding over time. And that's because to deliver this methodology and this idea across many different use cases, you have to be able to do it in a way that caters to where the developers are and what they're trying to accomplish. So I see the use cases is also growing over time to encompass not just these, but more applications that maybe don't quite fit the serverless model today. So, I started by talking about, Kubernetes, and Krish talked about Kubernetes as well. How do we use Kubernetes? Why do we even use Kubernetes? In some conversations when we're talking about serverless, I like to say that, there's no K in serverless, and that's true. But Kubernetes does have its power, and I think it can be wielded in just the right way. And the reason we use Kubernetes for our own platform, for our own development, is that it's everywhere. And 2 years ago, when we had started this journey with NIMBELLA and we founded the company, we wondered whether we needed to have this ability to deploy our platform on VMs and maybe even deploy Kubernetes on top of the VMs as part of our platform deployment. But then we realized, as we were talking with enterprise customers and early adopters and people who were willing to talk to us and give us feedback about what we were building, is that if an organization didn't already have Kubernetes expertise, they were acquiring it. And so that meant for us, we can push up the stack even faster. We didn't have to stay in the weeds and sort of worry about how do you actually install Kubernetes. That in itself is a complicated task. And the realization for us has been that the business value and the application value that organizations want to deliver is much higher up the stack. It's not in Kubernetes. It's not in the servers or the VMs or the infrastructure. And Kubernetes and container orchestration are really down at the layer of of things that aren't business value at the end of the day. And so our journey has been to push up this stack. And Kubernetes itself, not to sort of hamper on it, but it is complicated. And I'm not alone in this view. This is widely held view in my opinion. And Kelsey Hightower, I was reminded of this precise point that he made almost a year ago, where Kelsey, if you don't know who he is very well-known Google evangelist and developer advocate, and has been involved in Kubernetes and Kubernetes advocacy and evangelization for some time. And he made this point that over time, Kubernetes itself will fade into the background. Right, it's part of the VMs and the hypervisors, but Kubernetes has some powerful APIs, and those remain, and those essentially surface and stick out essentially of your abstraction. And this was a year ago, and the reason I was reminded of this point that he made is that Google this week announced Autopilot, and they call it a revolution in managed Kubernetes. So Kelsey tweeted about this, which is how I got to see it. But is it really a revolution? I don't think so. And the reason it's not is, what is Autopilot? If you really look through what it is, they've hid the servers, right? Google itself is recognizing that nobody really wants to manage the underlying infrastructure. It's really about pushing up the stack. And so the cloud providers themselves have incredible telemetry. They can optimize your infrastructure and your servers much better than you can at the end of the day. And so while this isn't really a revolution in managed Kubernetes, it is a significant shift in how you approach using Kubernetes in the cloud. And this goes to my point about trap potential and unleashing that trap potential within an organization, right? So if you look at, where you are as an enterprise, and if you're not on the cloud today, then, we're talking about on-prem resource allocation. Right. How much of your organization or your budget is spent on infrastructure support and operations for your apps versus the amount of energy, amount of time, amount of money, and resources you have essentially allocated to core innovation and new development. If you're building your own infrastructure or you're maintaining your own infrastructure, it's probably disproportionately in the wrong direction. And by being able to shift and push more of the burden of infrastructure to the cloud providers, then you're able to unlock some of that potential. Shift the metrics to the area to bias towards core innovation and new development. And this is what's really powerful about digital transformations within the enterprise. Those that recognize the value in the cloud, but have some concerns about how do you actually get there. There was more to that tweet from Kelsey, and it was actually commenting about a point that Paul Johnston had made also a year ago, talking about, and Paul Johnston, for those who don't know, is a former AWS senior dev advocate for serverless. He's also well known and tweets a lot about sort of his views on serverless and technologies. And his point was, I hear a lot of CTOs who tell me that Kubernetes allows them to have this idea that they can move to another cloud. And that number is huge. A lot of essentially people in a lot of CTOs have that opinion. But in the same vein, the number of CTOs that think that cloud migration is essentially impossible or impractical is about the same. It's not necessarily the same people, but the same number. So why Kubernetes? What does Kubernetes really deliver for you at the end of the day? Kubernetes by itself, and I think the point that is hinted at by some of these points, is that it doesn't give you portability by itself. And there's a number of points as to why that is. So let's consider three questions. Are you rolling your own Kubernetes? And by that, I mean you're deploying your own Kubernetes distribution on VMs. So if you're on AWS, you provision EC2 instances, and then you install Kubernetes on top of that. If you're on Google, you might be doing the same. Or are you using a managed Kubernetes service? Once you start making that distinction, you're already locking yourself into choices that become hard to reverse and start to eat away at portability. Moreover, if you decide to roll your own Kubernetes and manage all of the infrastructure yourself, my question to you is, how big is your IT budget? And do you know how much Google or AWS or Microsoft or IBM spend on their IT budget for managing and operating their clouds? And lastly, a fundamental point here is, do you forego cloud native development? And by cloud native here, I mean using the services from the cloud providers as they offer them to you. So that means completely shifting the burden of what you're doing to the cloud providers. And so one way that you would do that is, maybe use a managed Kubernetes service. What if you need other APIs that you want to consume? What about storage? How much of that are you willing to roll on your own? And I think giving up or foregoing cloud native services really is a fundamentally diametrically opposed value proposition when you consider, hey, that I'm trying to modernize my cloud infrastructure by moving to the cloud. And as Chris said, I believe that serverless is the way. And I also say that serverless is inevitable precisely because of a lot of the points that he said. And just as Kubernetes essentially is going to fade into the deep layers of stack for APIs to emerge, everything in the cloud today is already consumable by APIs. And this is the great enabler in my view. And serverless with NIMBELLA is cloud portability. Now, let me define what I mean by cloud portability in this sense. I mean a single source of truth. My code lives in the source control, so GitHub, for example, and can be deployed on multiple clouds, whether it's AWS, Google, Azure, or a private cloud. Just your code, no additional configuration, nothing else to worry about. And it's done in a way that's repeatable. And not just by one developer, but any developer within an organization. And I mean potentially an entire application, not just an API, but the front-end assets that the API might need, the back-end assets, whether it needs object storage or key value storage, all of that resource and infrastructure should be provisioned for me in the same way that serverless says, hey, you get to be hands-off and focus on your value creation. How much more can you do for that? And so at NIMBELLA, we try to deliver on essentially this promise. By implementing a number of key features. I'm going to get into the architecture in a little bit. But the idea is that you can run on a NIMBELLA cloud, hosted and self-managed by us at NIMBELLA, or you can take this cloud and deploy it on your own using our distribution, our cloud distribution, and put it on the cloud of your choice within your VPC, your virtual private cloud, or other private infrastructure. And how do we do this? We do it in two ways. One, by treating the cloud providers as a commodity. And second, it's fundamentally not about boiling the ocean, right? It's about integrating foundational services and doing it in a way that's cloud native. This is again going back to the point that the cloud providers are investing a lot and pushing the technology out into the, making it easier, frictionless, delivering more value to end users. And so if you, at the end of the day, you care about cloud portability and you care about having some level of control, but you don't want to use cloud native, then you're defeating the purpose of moving to the cloud. So can you do this combination of, I want the best of the clouds, but I want it on my terms? And this is what NIMBELLA delivers. And we do it by focusing on three foundational aspects: compute, storage, and network. And there's a lot more that if you go to a cloud provider and you look at their console, they offer you dozens of services, if not 100 services or more. This is not what we're trying to do. We're not trying to replicate everything that there is. But we recognize that there are key foundational pieces that are building blocks for any modern day application. And this is where we focus. So the NIMBELLA platform architecture consists of components and services that get deployed within a Kubernetes cluster. But it's done in a way where we can leverage the underlying cloud native services. But those abstractions we try not to leak. Or, no abstraction is completely leak proof. And there are mechanisms to essentially get at the underlying resources. But if you're building an application on a NIMBELLA cloud, you don't have to care whether you're on cloud A or cloud B. And if you're deploying this on a cloud of your choice, then you can isolate the resources in many different ways. The developer tools and the management tools essentially are part of the abstraction, are on top of the abstraction. These are the things that humans touch. Everything else is automated and part of the automation that Nimbella offers. And the way we deploy our microservices and services that we use to enable this developer experience is by using Kubernetes, but doing it in a way we can also leverage key value store that a cloud might host, an object storage, so S3 or Google storage, and maybe in some cases, not just using our own functions engine for running functions as a service, where we use Apache OpenWhisk, and we also have some technology for running V8 isolates, but other technologies that might be available to us on a particular cloud, whether it's Amazon Lambda, Azure Functions, Google Cloud. The point is, it doesn't matter the implementation choice for how an API gets mapped to a function as a service, or if you're using containers, because you're still, in the container-first world, whether it's Docker or a Knative compliant runtime, your developers at the end of the day should not care. This is part of the implementation strategies that the platform should optimize. And these are specifically what we're going after. So when you create a function and you deploy it into the Nimbella platform, in some cases it might run as part of the Apache OpenWhisk runtime. And in some scenarios, we might want to optimize and run that code for you in a V8 isolate, because it gives us better density, it gives us better performance, but it requires that we know something about that code. Furthermore, the choice of whether we use one particular technology versus another might depend on whether you're touching state and you need really low latency access to that state, or we're enabling some optimizations within the platform to deliver better performance when you're doing AI and ML. I'm going to touch on some of those a bit later. So there are scenarios where you really need to leverage the underlying cloud that you're running on to deliver some of the value. Also part of the Nimbella platform and the value proposition here is that, as we've worked through some of these use cases with our early enterprise developers, we found that we've needed to build adaptations to allow them to use logging infrastructure that they already use, or monitoring infrastructure that they already use, or to complement what they have with new views that are specific to what they're trying to monitor. Identity management, security, and role-based access, all fundamentally important in an enterprise. And we've had to figure out how to sort of do it in a way that allows us to deliver a value proposition to the end users. Our developer tools are completely open source in terms of the CLI that developers use, including our Postman plugin. We have a Workbench, which is a browser-based version of the developer CI. It's an open core license. And that allows you to essentially touch your cloud platform from your browser, no tools installed. That happens to be sometimes quite convenient to do, especially if you're on a mobile device and you want to check something. I often do that with our own platform. And we've also built management tools that are bespoke that automate a lot of the underlying complexity with managing a Kubernetes cluster. Right? So you're deploying services. There's a lot of YAML, even if you're using infrastructure as code that you have to deal with. And when you're dealing with a Kubernetes deployment, there are still things that are finicky, races, liveness probes that don't quite work the way you expect. And you have to do a lot of automation to sort of deal with that. And not just deal with it when it goes wrong, but provide mechanisms to self-heal the platform and recover from errors that might happen. And so we've built a lot of these automations to allow us to address some of these points that we've encountered as we've gone along. So what does this mean for the enterprise? At the end of the day, it's about focus, right? By shedding a lot of this burden to the underlying cloud provider and the underlying cloud platform, whether you're shedding servers or reducing the amount of servers that you're managing, having this ability to auto scale and have the infrastructure deal with a lot of the compute capacity and compute management gives you the benefit of faster time to production and increased infrastructure costs. And it's not just infrastructure costs in terms of dollars paid to the cloud providers, but it's your internal budgets in terms of the people and the teams that you're hiring to manage the internal infrastructure. So, in my question to Krish, I was sort of reflecting on this point. And I think, serverless is about focus. It's about creating value faster. And our one-click deployment is about automation and serverless integration to empower small teams to unleash their trapped potential within your enterprise. And this really goes back to sort of the theme of my talk and what I chose to title it. if you don't have large teams dedicated to infrastructure management, you can retrain that workforce. You can have them deliver value in new ways. There's several other benefits I sort of wanted to touch on with the NIMBELLA cloud platform. A lot of the developer and user administration that we've built are designed to facilitate collaboration, right? So Krish gave this example of I'm developing something, it's in a staging environment, I'm collaborating with others, then it gets promoted to another environment, and then finally to a production environment. None of those things in a real application in the enterprise are done by single developers. Maybe initially, but at some point, if they're successful, there are teams of people who have to work on these things. So can you do this development in a way that not only encourages collaboration, but makes collaboration possible to where multiple developers can have replicated and repeatable environments for them to develop and test on? We've built data management into the platform because we think any interesting application has state that you have to manage. I'm going to talk about this in a couple of slides. We're not about changing the way that you work fundamentally in terms of GitOps and CI/CD. All of these things are good software engineering practices that your organization should have. And we're about complementing what you have and giving you more. And the idea that you can take this platform, run it in an Embellish.com, for example, where it's completely managed, or deploy it on a cloud of your choice is something that we found both validation in the market and use cases where we can deploy the platform within a virtual private cloud and deliver value to our enterprise partner. The benefits for developers are many, not just, we've touched on a lot of what you get out of just being a serverless developer before, but there's other benefits from an organizational perspective that you can deliver to your teams when you control some of this platform. Whether it's the runtimes and libraries that you use for running your serverless functions or your containers, the programming models can be tuned for an organization. For example, you can have normalized flows for how you authenticate, secure, and audit APIs. Bespoke performance optimizations, right? If you have some control over the platform, you can't go in and tinker with Amazon's infrastructure, but you may be able to sort of do certain things when you retain a level of control. And I'm going to call out a couple of these when I talk about state management that we found to be important. Support for long-running functions, custom workflows is another potential customization areas we've seen, and integration with existing logging, monitoring, security tools. The auditing and the security integration that you can get for free. Again, it's about allowing developers to write less code, have the platform take care of more for you, and shifting that burden so that as a developer, I'm not only writing more secure code because it's done for me and automated for me, but I'm able to sort of focus on the things that are important at the end of the day. And to get into some of the state management that we do, I want to talk about the anatomy of a cloud application, right? So there's lots of things, lots of components that you have to work on. A lot of these fall into networking, storage, and compute. And in the area of state management, there's databases, web buckets, object storage, key value store. I'm going to focus on 3 of them in the interest of time here. And the first one is inadequate solutions for fine-grained data sharing. The stateless nature of serverless platforms today make it difficult for a serverless function, if you will, or serverless API to share state with another. Maybe you have to provision a key value store for that. The performance, the cloud doesn't guarantee that your code and your data is co-located. Latency and the performance just might not be there. Some examples of this: turning on debugging when you get an alert and you want to essentially turn on debugging and increase the amount of logging from your APIs, changing configuration parameters on the fly. Maybe you're canary testing, you want to change your sampling rates. Session state, authentication flows, payment processing, progress meters, counters for telemetry. There's a lot of use cases where having a key value store fundamentally integrated with your platform is just faster and better way of developing things. And that's one of the technologies we've built into NIMBELLA. And it's the ability not just to have a key value store readily available, you can use it from any of your API implementations, but it's that you can have this sub-millisecond latency between your functions and your key value store. And that's because in some cases, when you are using or making use of this technology, we can co-locate your compute and your storage within the same cluster, within the same nodes, within the same VMs, depending on the level of optimization that's desired. The other one is when you're running in this functional model, serverless functions model, it's hands off to you. You don't know where any of your functions or your APIs are going to run. And that's part of the contract between you and the cloud provider and how they can deliver you, 1,000-way parallelism and concurrency for your APIs. But as part of that, you're losing transient occupancy. If you don't know where your functions run, you can't keep any kind of data locality. Maybe you can do some optimizations, but at the end of the day, it's impacting performance and impacting dollar costs. An example of this is AI and ML applications, where if you're doing inference, as Krish pointed out in his example, and you have 1,000 instances of this API running, every one of those needs a copy of that model. Are you going to fetch that from your object store every time? Well, that's an optimization that the platform can make for you, right? So you can use a declarative approach that says, hey, save this model and share it for me across all my compute resources. I don't want to worry about managing it at all. And that's part of the optimizations we've built into the platform. In essence, we're restoring data locality to accommodate data gravity, and this also helps you with portable serverless compute. If you have significant data gravity and you can run the same environment in multiple clouds, then ship the compute, don't ship the data, right? It's often much cheaper to do that. And the way we do this is by essentially breaking up the computation into logical steps and then taking over some of the management. So if you think of every execution of an API as being three-phased in an actor-oriented model, then you worry about the logic. We'll take care of what happens before and after, and that might involve reading data from a database, a key value store, or an object store, and then giving you the right abstractions within your logic. The NIMBELLA cloud itself runs on other clouds. So we are in AWS today and Google Cloud. We are also in several private clouds. You can run it fully managed. And as I alluded to before, you can deploy it in your own organizations and your own VPCs. Where do we add the most value to our enterprise adopters? 3 areas. So if you believe that serverless is the future, but you need a gentle migration path, NIMBELLA is for you. If you're already investing in Kubernetes and you're concerned about essentially exposing Kubernetes complexity to developers, then NIMBELLA can help you. And if you care about portability or some control, not over all of your cloud infrastructure, but some, then NIMBELLA could also be for you. So that ends my talk, and I'm going to bring Krish back onto the screen. Hopefully I can do this correctly. And you can download this white paper that Krish has written. It's on our webpage, nimbella.com/whitepaper. And you can reach Krish on Twitter or via email. Same with me. Those details on the slides. So Krish, we're about out of time.
Yeah.
I thought
that was a great presentation.
Thank you. Yeah, so I thought we would just conclude with any final thoughts or comments that you wanted to make.
Yeah, I think every organization thinking about modernization should find ways to sort of reduce the friction. And I think that serverless abstraction is the right abstraction for reducing friction and empowering the developers. So if you believe your developers can bring in innovation at a pace your business needs, probably give them that abstraction, serverless abstraction, that will help them accelerate their innovation. And based on my analysis of various platforms in the market, NIMBELLA as sort of like meets most of the criteria needed by the enterprise customers. And I strongly recommend that you take a look at NIMBELLA platform and see if it fits into your needs. I think NIMBELLA is doing a great job in terms of making serverless even more accessible.
Thank you, Krish. And we've been incredibly lucky to have patient enterprise adopters who have helped us refine and sort of figure out how the product serves and adds value to them. It's been an incredible journey. I'm thankful for where we are and excited about where we're going. So thanks, Krish, for joining me. And this concludes our talk. Thanks for everyone who's watched.